exactly, precisely the same way you have to represent. Just, this, you can show one single, flow of heat from left to right. You see why this is shown as plus and this is minus. It is flowing in this direction, this is gaining heat and this is losing heat. That's the reason why. You need not even represent all these heat transfer. Just simply one plane, another plane, and then sheet. Symbolically to show that there is surface resistance on either side, sigma s. Then A1, T1, epsilon 1, A2, T2, epsilon 2. AS is that's it. That much you have to represent. See, while drawing the diagram, you should be conscious, right? So there is a distinction between the way the planes are shown and the sheet is shown. It's a very thin, sheet. Whereas, this has some physical form, some thickness, like solid thickness. Right. Now see what is the data that is given. Plates are maintained at 800 and 300. T1 is 800 plus 273, which is 1073 Kelvin. T2 300 degrees Celsius becomes 573 Kelvin. Their respective emissivities are 0.3 and 0.5. And the emissivity of sheet epsilon s is 0.0. For the sheet, emissivity will be very less compared to that of the plate. Right. So then you need to find the percentage reduction in heat transfer. Percentage reduction. See, the purpose of adding the seal is to reduce the heat transfer. Here it is asked how much percentage is reduced. What is the benefit that you know by? That's the question. Now the formula for this is, see, write down. Heat transfer between the two plates in the absence of shield or without shield. Heat transfer between the plates without shield. Let us say then Q0, Q0, where 0 represents 0 number of shields. Is equal to sigma A T1 to the power of 4 minus T2 to the power of 4 divided by 1 by epsilon 1 plus 1 by epsilon 2 minus 1. And I am assuming this numerator to be some constant C. You know, somewhere, right? Assuming this as constant, because I don't want to find, I need not find the independent values of heat transfer in the absence and in the presence. What I need to find is only the reduction. So therefore, I better avoid unnecessary calculations. Right? If you want, you can do nothing wrong. But then, right, for saving time, I am assuming this as some constant. You should write, taking this entire term as some constant. Divided by 1 by epsilon 1 is 0.3 plus epsilon 2 is 0.5 minus 1. This is equal to C by, someone may tell me this value. 4.3.
3.
Some more points after decimal. 3. Right. Now 1 by 4.33 value. Zero point 2307 into C. Let us assume this is some reference equation 1, right? Next, right. Heat transfer rate between the plates with one sheet between them. With one sheet between them, comma. Let's say this is QS almost with C. So what do we get here? Sigma A T1 to the power of 4 minus T2 to the power of 4 divided by 1 by epsilon 1 plus 1 by epsilon 2 plus 2 by epsilon S minus 2. 1 plus 1 is 2. So numerator is same as this,
C.
right? So I am writing this as
C.
some branch divided by 12 is
1 by 0.3.
43.33 is equal to
1 by
0.02
into C.
307
Into C.
into C. Let's say this is some reference equation. Now, percentage reduction is equal to percentage reduction is originally what was the heat transfer in the absence of sheet minus what is it when sheet is placed, that is the reduction, actual reduction in absolute terms, because it is asked as a percentage divided by Q0 into 100. Exactly 90? 90%. Any doubts here, anybody? Don't simply copy down the values that you see on the board. You do your own calculations. You may get 90.1 or 89.9. Don't know, depending on how many points you have taken after decimal. So, are you all agree with this value?
Yes, sir.
Right. Now come to the second part. Find the temperature of the sheet. You need to find Ts. So you have the equation here. Since Q1S is equal to Qs2, write this equation. In this entire equation, only unknown is Ts4 of 4. So try to optimize your calculations. When you do this, the next step is obviously you eliminate the common terms. Sigma into A,
Sigma into
is common. Right? You find this denominator. this one. So how should you write? T1 to the power of 4 minus Ts to the power of 4
by
divided by some value we get here
1 by
is
0
equal Ts to the power of 4 minus
t to the power of
T2
4.
to the power of 4 by you will get some value.
Yes, sir.
Right? You cross multiply and bring Ts to the left side, all others to the right side. Stop. What is this denominator? Resistance.
4.33.
Huh?
4.33.
This one, 4.33.
33.
So are you taking this as it is? There is a difference. This is 1 by epsilon 1 plus 1 by epsilon 2.
43.33.
This is 1 by epsilon 1 plus 1 by epsilon s. 22.33. 22.33. Here? 21 point? Exactly 21. Okay, 21 point. So then, 21 into T1 power 4 minus 21 into Ts to the power of 4 is equal to 22.33 into Ts to the power of 4 minus 22.33 Ts to the power of 4. Now 21 into T1 power 4. This is T2, right? Ts plus 22.33 into T2 to the power of 4, right, is equal to Ts to the power of 4 into 22.33 plus 21. So Ts to the power of 4 is equal to 21 into T1 to the power of 4 plus 22.33 into T2 to the power of 4 divided by, how much is this? 43.3, right? So tell me this value, this value. Now we get some value here, then fourth root of it. If you are using calculator, 914. Whatever value you get here to the power of 0.25, right? You will get some value here, over to the power of 1 by 4 or 0.25. 914. Precisely. Point nothing. 0.03. 3 or 03? 03 units. So because you have substituted, and in fact entire radius is given both in law in absolute Kelvin, absolute temperature Kelvin. So in degree Celsius, you subtract from it 641. So this is the temperature of the sheet.